Welcome back to the C programming language in action. In this module, we're going to look at the statements that may be used to execute code in different ways. What is and isn't a statement can get complicated. Declarations are statements. Expressions can become statements. Statements generally correspond to code that gets executed. That's why declarations are statements. When declaring a variable inside a function, you may and should include an initializer. That involves code to initialize the value of some variable every time the function is called. But I'm not going to get bogged down with technicalities. That's for the lawyers. What we need to concern ourselves with are the practicalities of how the various statements work to control selection, iteration, looping, and so on. Let's jump right in. In this segment, we're going to consider selection statements, ascertaining the most common of all statements. The most common selection statement is the if statement. Given some expression, an if statement may execute one statement or another. Before I show you an example, it will help to see an informal definition. So consider the pseudocode. The simplest if statement looks like this. The condition is some expression that evaluates to true or false, or something that is convertible to true or false, such as 0 for false and any other number for true. C++ also allows declarations as conditions, but most C compilers currently do not support this. The statement is only executed if the condition is true. The statement itself may be what's known as a compound statement. Compound statements are a sequence of statements surrounded by braces, just like the braces of this main function. So I could also write, within those braces I can add any number of statements, or I can leave it empty. Usually, when braces are involved to produce a compound statement, the braces are aligned in one of 2 or 3 different styles, using white space to make it look more structured. But the compiler doesn't care about white space, so it's purely for your own benefit as you read the code. This helps us to see the logical structure of execution, using the braces along with indentation to clearly distinguish what will happen if and only if the condition is true. Now, what happens if you want to do one thing if the condition is true and another if not? Well, you could follow the one if statement with another. The exclamation mark is the logical not or negation operator. So this is one way to do it, but it involves repeating the expression or writing the opposite, which can be quite error-prone or at least tedious. Fortunately, the if statement covers this scenario nicely with an optional second statement. Okay, so that's the basic idea. Let me give you a real example that we can test with a compiler. Now let's see. We have some eggs. Now, do we have enough eggs to make a cake? If so, otherwise, if we don't have enough eggs, okay, let's see what happens. Great, we get cake. Now, let's see what happens if we don't have enough eggs. And while we're here, let's clean up this if statement. While this is strictly speaking fine by the compiler, I almost always use compound statements with if statements as it makes the code easier to read and easier to extend in the future. Again, this code is equivalent exactly to what we had before. It's just easier for us to read. At least it will be once you get used to the idea of braces and indentation for both logical and physical structure. Okay, let's see if we have enough eggs. No cake today. Sad face. So the if statement is the most common of the selection statements, but there is another called a switch statement. You need to be careful with this one. It's one of the most inconsistent parts of the language, and it's also part of C++, so take note as you're likely to come across it from time to time. Some compilers may generate better code, but I wouldn't put it past my compiler's optimizer to make the difference negligible in most cases. Write the code that's easiest to read. Unlike the if statement, it's easier to understand the switch statement with an example. The switch statement allows you to pick from a set of alternative statements to execute, based on the value of the condition, the value of the eggs variable in this case. If there are no eggs, I'll show you why the break is important in a moment. So that's the first case. If there are no eggs, then print no cake. But if there is exactly one egg, then perhaps we can afford to make a cupcake. Otherwise, we should be able to produce a real cake. Notice the default instead of the case label. This catches any values that are not covered by case labels, but it is optional, so you can choose to do nothing if none of the values match. Also, the default label need not appear at the end. That's just conventional. One of the restrictions of the switch statement compared with the if statement is that these case values, 0 and 1 in this case, these values must be constant expressions. If that won't do, then you need to use an if statement. But let's give this a quick try. Okay, great, we get a cupcake. Now what if we have lots of eggs? Great, the default case is hit and we get some cake. But be careful with the default case. It may accept values you weren't expecting. The integer variable may hold both positive and negative values. In this case, we still get cake. The switch statement doesn't know that -12 isn't a valid number of eggs. Right, now let's consider syntax for a moment. When it came to the if statement, I recommended using compound statements, the curly braces to clearly identify the actions or statements that would execute if the condition were true or false. Well, the trouble with a switch statement is that it breaks some of these fundamental conventions of syntax in C and C++. Let me show you what happens when I remove the break statements. Now we have 0 eggs, so the program dutifully prints out no cake, and cupcake, and cake. What's going on? Well, let's change the number of eggs to 1. Now it only prints cupcake and cake. You see, the switch statement finds the appropriate label and executes the code from there. Unless a break statement is found to terminate the switch statement, execution simply continues or falls through to any subsequent statements. So in this case, we have 1 egg. That matches the cupcake, and then execution simply falls through and continues to execute any remaining statements. In this case, those following the default label. So it might be tempting to write something like this. And that's perfectly fine. But again, that won't make any difference unless a break statement is added. Where the break goes has nothing to do with the curly braces. You could just as well put it here. So keep that in mind as you work with a switch statement. It can sometimes be handy, but you need to be careful with it. If you prefer, you can safely rewrite the switch statement with a set of if statements. That's no cake. Cupcake. And cake. Now, there's no need for break statements. There's no fall-through, and it's clear what will happen and when. Notice how you can also chain together the if statements. There's no else if statement in C or C++. This is a separate if statement that is executed only if the original if statement's condition is false. It is equivalent to writing it inside a compound statement, but allows for more if statements to be chained quite conveniently. In this segment, we're going to consider two related statements, while and do. The previous if and switch statements are C's selection statements. While and do are iteration statements. Iteration statements are useful for implementing a loop. You can express some statement or compound statement that you want to execute some number of times based on a condition. Similar to the if statement, except that the statement may be executed repeatedly. Oh, and there's no else on an iteration statement. But let's take a look. The while statement is the easier one to comprehend. Start with an if statement. So if count is less than 10, then do something. We just print out the value. Okay, let's give this a try, although by now you should know what will happen. So count is less than 10, so the count is printed out and the program comes to an end. Now let's change this to a while statement, often called a while loop. That's all it takes. While this condition is true, while count is less than 10, execute the compound statement, often called the body of the loop. Okay, I assume you saw that coming. This program is stuck now in an infinite loop. Since the condition is true and never changes, it just keeps repeating the statement associated with a while loop. So that's great, but presumably we want the loop to come to an end sometime. So we might change the variable, which will indirectly change the condition. Now, after printing out the count, 1 is added to the count variable's value. Eventually, the count will be 10, and the while loop's condition will no longer be true. Let's see. Wonderful. The count reaches 9, the condition is true, the message is printed out, the count is incremented, this time the condition is false, and the statement is not executed again. Instead, execution continues after the while loop, and the program promptly comes to an end. It's important to realize that the statement is only executed if the condition is true at least once. So the condition is evaluated before the statement is executed, before the body of the loop is executed. If we change the program like this, now the condition should never hold and the count should never be printed out. Great, nothing to do. The reason it helps to keep this in mind is that this is the chief difference between the while statement and the do statement. Let's now take this condition and move it to the end of the statement, following the body of the loop, and add do to the front. And that's the do statement. The condition literally comes after the body or statement, reminding you that the body is always executed before the condition is checked. Notice that the count is still 10, so the condition is false. The previous while loop didn't print anything out, since the condition is false. But now let's see what happens. And there you can see that the statement associated with the loop, the body of the loop, executed once before the condition was checked and the loop terminated. This might seem convenient, but you are now assuming that any assumptions made within the body of the loop will always hold true at least once, at least the first time. This is a common source of bugs, so I'd avoid it unless you're really sure that this is what you want. In this segment, we're going to look at the mighty for statement, the most powerful iteration statement, but potentially also a source of bugs. Let's return to the simple while loop. So we have our loop variable called count. We have our condition if count is less than 10. And we have an expression statement that updates the loop variable. The for statement formalizes these three artifacts and places them front and center. First, let's rename while to for. Then take the loop variable and place it before the loop condition. And finally, take the expression updating the loop variable and place it after the loop condition. This is now the equivalent of the while loop using the for statement. The loop variable is first initialized. The loop condition is evaluated. If its outcome is true, the body of the loop is executed. If not, execution continues following the for statement. After the body is executed, the expression updating the loop variable is executed and the loop condition is again evaluated, and so on. And this continues until the loop terminates. Of course, this loop will not execute its body, since count starts at 10, and this does not satisfy the condition. It's easier to see such things at a glance with a for statement. So let's change the initializer to 0 and take it for a spin. And there's our count from 0 through 9 as expected. The interesting thing about the for statement is that any one of these three may be omitted. We can, for example, use a loop variable declared elsewhere. This is fine and has the same effect, but now the count variable is visible beyond the for statement, again potentially a source of bugs. You should always try to keep a variable as limited and local as possible. Still, this is legal if you need it. You can also omit the expression updating the loop variable. Again, this is fine. But what might be somewhat surprising is that you can even omit the loop's condition expression itself. In that case, the condition is assumed to be true, and the loop will, well, loop indefinitely, or until you terminate it in some other way. Here again, I'm using the break statement I first introduced with a switch statement. It can also be used to break out of a loop statement and causes execution to commence following the loop. This works just as well with a while statement, by the way. This now is again equivalent to the original while statement, as well as the original for statement with the three parts of the for statement neatly in line. The main difference is that the loop condition is not actually checked up front, although we know visually that the condition will hold at least once. The body is then executed, which includes the statement updating the loop variable and the if statement evaluating the loop condition manually. Let's give it a try. And sure enough, 0 through 9 again. Well, that concludes the primary statements provided by the C programming language for selection and iteration. We considered the if statement the most widely used statement for selection or control flow. If some condition expression is true, then the associated statement or compound statement is executed. If not, execution continues at the next statement, if any. There's also the if-else variant that provides a statement to execute either when the condition is true or when it's false. That's also a good time to consider whether to use compound statements, curly braces for readability. Then there's the mighty switch statement. Dennis Ritchie finished designing C. It was beautiful. He went out to celebrate, had a little too much to drink, and added the switch statement. Seriously though, the switch statement can come in handy, and there are times when it generates optimal code due to its requirement for constant expressions. It's just not very consistent with the rest of the statements and language design. I can see how a developer with a strong background in assembler would like the switch statement very much, with its labels and seamless control flow. Next up is the simplest iteration or loop statement. The while loop should be your first choice for looping or executing some statement repeatedly, at least in C. C++ offers a range for statement and many algorithms which are preferred, but C doesn't have many of those options at present. The do-while statement offers an alternative when you absolutely must execute the statement at least once. And then the for statement gives you a lot of control over iteration in a more condensed syntax. Nothing you couldn't write with a while loop, but it is more convenient and safe in many cases, since you can include a declaration which the other statements cannot, at least in C.